Assalamualaikum warahmatullahi wabarakatuh. We from Group C from class DSP sections 5 would like to present our project entitled Audio Noise Reduction through Digital Signal Processing. Okay, for this project, background noise can reduce speech quality and make communication difficult, especially in online meeting, voice recording and communication system. Therefore, the objective of this project is to reduce unwanted background noise and improve the clarity of audio using digital signal processing technique.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Quizwan bin Isa and my number metric is CE230153. So I will continue present our group project, which is the methodology of our project. So the entire system was developed using MATLAB R2034B together with the signal processing toolbox. The first step was recording a real voice using a mobile phone. The recorded audio was then imported into MATLAB using the audio read bracket function. Then the audio was converted into a mono signal and normalized to avoid clipping during processing. Next, White Gaussian Noise was added to the clean voice signal. This step simulates background noise that commonly occurs during recording or communication. Then after that, we designed a 120 TH or the FIR Low-Pass Filter using the FIR 1 bracket function with a Hamming window. The filter has a cut-off frequency of 4000 Hz and a sampling frequency of 48 kHz. These parameters were selected because we know that most human speech is below 4 kHz, while higher frequency components mainly contain noise. The noisy signal was then passed through the FIR filter using the filter bracket function to remove the unwanted high frequency noise. After filtering, the several analyses were carried out. First, we compared the waveform in the time domain. Then we performed FFT analysis to observe the frequency component of the signal. We also analyzed the frequency response, impulse response, spectrogram, and finally calculated the signal to noise ratio to evaluate the filter performance. That's all from me. Thank you.
So right now I will present about the result and discussion for this project. So firstly we open the file of the simulation. So basically this project was developed entirely in MATLAB R2024B using the signal processing toolbox. So the program consists of several stages including audio acquisition, noise addition, FIR filter design, FFT analysis and performance evaluation. So our group use a real voice recording and we import into the MATLAB using the audio read function. The audio is converted into a mono signal and normalized before processing. So I will show the demo.
Hello everyone, this project demonstrates audio noise reduction using digital signal processing. First, the original speech signal is recorded, then White Gaussian noise is added to simulate the environmental interference. Finally, an FIR low-pass filter is applied to reduce the noise while preserving the original speech. Hello everyone, this project demonstrates audio noise reduction using digital signal processing. First, the original speech signal is recorded, then White Gaussian noise is added to simulate the environmental interference. Finally, an FIR low-pass filter is applied to reduce the noise while preserving the original speech. Hello everyone, this project demonstrates audio noise reduction using digital signal processing. First, the original speech signal is recorded, then White Gaussian noise is added to simulate the environmental interference. Finally, an FIR low-pass filter is applied to reduce the noise while preserving the original speech.
So basically as we can see here, the simulation will playing the original voice and it will put the noise into the voice, and lastly it will filter the voice as we want, and it will show the 8 figures that we have set up, and I will explain the figures one by one. So this is the 8 figures that we have set up in the MATLAB simulation. So I will explain the figures one by one. So the firstly is figure 1, we can clearly see the filtered signal become smoother while maintaining the original speech waveform. And then the figure 2, this zoom waveform clearly shows that random fluctuations are reduced after filtering. And then figure 3 is about the FFT converts the signal into the frequency domain. After filtering, the high frequency components are reduced while the useful speech frequency remain. The figure 4, this is the frequency response of the FIR filter. Frequencies below 4 kHz pass through while higher frequencies are attenuated. Figure 5, the impulse response is symmetrical, confirming that the FIR filter has a linear phase response. And then the figure 7, the spectrogram shows that the background noise is reduced after filtering while the speech components remain visible. And then lastly we have figure 8, which is the SNR increased from 13.93 dB to 15.89 dB, proving that the filter successfully improved the audio quality. I think that's all. Thank you.
So in conclusion, this project successfully developed an audio noise reduction system using an FIR low-pass filter in MATLAB. A real voice recording was used as the input signal, and White Gaussian noise was added to simulate a noisy environment. The noisy signal was then filtered using a 120 order FIR low-pass filter designed with a Hamming window. The simulation results show that the filter effectively reduced background noise while preserving the important speech components. This was verified through waveform analysis, FFT analysis, frequency response, impulse response, spectrogram analysis, and finally SNR evaluation. Overall, all the project objectives were successfully achieved. This project also helped us understand the practical application of digital signal processing techniques, especially FIR filtering and FFT analysis, improving speech quality. Thank you for your attention.